Imagine a massive airplane traveling thousands of meters above the Earth, hundreds of passengers sitting quietly, two powerful engines producing enormous amounts of thrust, thousands of sensors working continuously. Everything appears perfectly normal, and then something goes wrong. Within seconds, the aircraft disappears from radar screens. Investigators arrive. The wreckage is scattered everywhere. Questions begin to appear. What happened? Why did it happen? Could it have been prevented? And that's when everyone starts searching for one thing: the black box, a device no larger than a small suitcase, yet powerful enough to reveal the final moments of an entire flight. But here's the surprising part: the black box isn't black at all. It's bright orange. It can survive explosions, violent impacts, extreme pressure, intense fires, and even the crushing depths of the ocean. Somehow, this remarkable machine continues protecting its information when almost everything else has been destroyed. But how can a small metal box survive conditions that destroy an entire aircraft? And how does it help engineers understand exactly what happened? Today, we're exploring the incredible engineering behind one of the most important devices in aviation history, the black box. The name black box sounds mysterious, almost secret, but the truth is very different. First of all, the black box isn't black, it's bright orange, because investigators need to find it as quickly as possible. A bright color makes it easier to spot among the wreckage, especially in forests, mountains, snow, or even deep water. But here's something even more surprising: there isn't just one black box. Most airplanes actually carry two separate devices. The first is called the flight data recorder, or simply the FDR. Its job is to record thousands of measurements: altitude, speed, engine performance, fuel levels, cabin pressure, wing movements, and information from hundreds of sensors every second. The second device is called the cockpit voice recorder, or the CVR. This recorder captures everything happening inside the cockpit: conversations, warning alarms, switch movements, and even the sounds of the engines. Together, these two devices create an incredibly detailed picture of the flight. Investigators can later study this information to discover exactly what happened, but collecting the information is only half the challenge. The real challenge is protecting it, because once an accident happens, the black box must survive conditions that almost nothing else can withstand: extreme heat, massive pressure, violent impacts, and powerful explosions. And that's exactly what engineers designed it to do. Now comes the most incredible part: how can small metal box survive when an entire airplane cannot? The answer lies in its construction. The outer shell is not made from ordinary metal. Engineers use extremely strong materials such as titanium or stainless steel. These materials can withstand enormous amounts of force. Inside, several protective layers surround the memory unit. Each layer absorbs part of the impact, reducing the force that reaches the recorded data. Then comes another challenge. Fire. A plane crash can create temperatures higher than 1000 degrees Celsius, yet the black box must continue protecting its information. To achieve this, engineers place special insulation around the memory system. This insulation acts like a protective shield, keeping the inside cool enough to preserve the stored data. The box must also survive extreme pressure. Sometimes aircraft wreckage falls thousands of meters below the ocean surface. At such depths, the surrounding pressure is enormous, powerful enough to crush many objects instantly. But the black box remains sealed, protecting everything stored inside. Before approval, every black box is subjected to brutal tests. It is burned, frozen, crushed, dropped at incredible speeds, and exposed to intense pressure. Only after passing every test is it allowed to fly, because when disaster strikes, this tiny device may become the only witness to what happened, and every second of information could save lives. In the future, finding the black box can be just as difficult as building it. Sometimes the wreckage lies deep inside forests, sometimes on mountains, and sometimes thousands of meters below the ocean, yet investigators still manage to find it. But how? The answer begins with a tiny device attached to the recorder. This device is called an underwater locator beacon. The moment the black box touches water, the beacon activates automatically. Then, every second, it sends powerful sound pulses into the ocean again and again and again. Special ships travel to the area using sensitive equipment to detect these signals. The deeper the recorder falls, the harder the search becomes. Powerful currents can move the wreckage, storms can delay the investigation, and sometimes investigators search for weeks or even months. Robotic submarines are often used. These machines travel into the darkness, scanning the ocean floor, searching for the bright orange box. The recorder may be damaged, burned, bent, or buried under debris, but if the memory unit remains intact, the information can still be recovered. Every sound, every warning, every movement, every second. Slowly, the final moments of the flight begin to reveal themselves, and investigators start building a complete picture of what happened. Because the black box doesn't simply record information, it tells the story of the flight itself. Finding the black box is only the beginning. Now, investigators must discover what the information actually means. The recorder is carefully opened piece by piece. Every component is inspected. Even the smallest fragment could contain important evidence. If the outer shell has been damaged, engineers carefully remove the memory unit. This process can take hours, days, or even weeks, especially if the recorder has been exposed to fire, saltwater, or violent impacts. Once the memory is recovered, special computers begin processing the information. Thousands of measurements appear on the screen: altitude, speed, engine temperature, fuel pressure, flight direction, control movements, and countless other details. Then, investigators study the cockpit voice recorder, every conversation, every warning sound, every alarm, every switch movement. Even the sound of the engines can provide important clues. Using all this information, engineers create a timeline, second by second, moment by moment. Eventually, a complete picture begins to appear. Investigators discover what happened, how it happened, and sometimes why it happened. The purpose isn't to assign blame. The purpose is to learn, because every lesson can help prevent another accident, and every discovery makes air travel safer for millions of people around the world. Technology never stops evolving, and neither do black boxes. For decades, these devices have protected some of aviation's most valuable information, but engineers are now asking an important question: what if the data never needed to be recovered at all? What if the aircraft could send its information directly to the ground in real time? Around the world, researchers are exploring exactly this idea. Instead of storing everything inside one device, important information could be transmitted through satellites immediately. Engineers could monitor critical systems while the aircraft is still flying. This approach could save valuable time, especially when accidents happen in remote areas or deep oceans. However, this technology also creates new challenges. The amount of information produced by modern aircraft is enormous. Transmitting all of it would require powerful communication systems, massive storage capacity, and extremely secure networks. Another challenge is reliability. Black boxes have already proven their strength for decades. Any replacement must be as dependable. For now, most experts believe that traditional black boxes will continue to exist, perhaps working alongside new technologies combining physical storage, artificial intelligence, and satellite communication, creating an even safer aviation system. Because no matter how technology changes, one goal will always remain exactly the same: finding answers, protecting lives, and preventing future disasters. So, how does a black box survive a plane crash? The answer is simple: extraordinary engineering, a strong outer shell, powerful insulation, multiple protective layers, advanced memory systems, and years of scientific research working together. Every second of every flight, the black box records Thousands of details, conversations, warnings, engine performance, speed, altitude, and countless other measurements. Then, if disaster strikes, it protects that information against fire, pressure, explosions, water. Violent impacts. Investigators search for it, recover it, study it, and slowly piece together the final moments of the flight. These discoveries help engineers improve aircraft, develop safer systems, train pilots, and protect millions of passengers around the world. The black box may be small, but its mission is enormous, because inside this remarkable machine lies something far more valuable than metal: information, knowledge, and lessons that save lives. The next time you board an airplane, remember that somewhere inside the aircraft, a silent witness is working, recording everything, watching everything, ready to reveal the truth if the unthinkable ever happens. If you enjoyed this documentary, don't forget to like, share, and subscribe to RailForge, because here we explore the engineering behind the world's greatest inventions, machines, and technologies. Thanks for watching, and we'll see you in the next documentary.